Hello everyone. In this video I'd like to talk about finding areas in between curves when we have intersections involved. So this makes it a little bit trickier and it generalizes so that we can find areas of region. So what do I mean by a region? Well, maybe instead of using bounds of integration between curves like that, we just have regions that are closed by curves. So I have a curve here, maybe I have a curve here, maybe I have a curve here. We want to find that region in there. Something like that. And that makes it harder because we need to find our integration bounds by ourselves. So this is going to be a little bit trickier, and this is going to be a little bit about what we talk about in this part of Unit 5 in our area between curves mini-unit. All right, so let's get started with our example. So we would like to find the area in the region bounded by 4x squared minus 1 and cosine of pi x. All right, now to find our intersection, it should be pretty obvious what we need to do. We need to set these functions equal to one another. Now you have cosine of pi x is equal to 4x squared minus 1. Now this looks pretty nasty. This is a nasty equation to solve. This method of setting these equal to each other usually works best when we are dealing with algebraic functions, and that should be pretty obvious. So what we're going to do this time is we're going to do something a little bit simpler, and we're going to look at the zeros of our functions. So let's look at our parabola first. So what we do is we set 4x squared minus 1 equal to 0. And that gives us x squared is equal to 1/4. That means that x is equal to the positive or negative case of 1/2. Now for a cosine wave, we need to determine which value of x in this argument with pi is equal to 0. Now for cosine, any interval of pi over 2 is equal to 0. So cosine of pi over 2, 0. Cosine negative pi over 2 is 0. So what value of x would make this value pi over 2? Well, if x is set equal to 1/2, then pi times 1/2 is equal to pi over 2. That sets our cosine function equal to 0. So that means that our x value for our cosine zeros, the only zeros that are going to be important are, of course, plus or minus 1/2. And of course, we can see these zeros are our intersection values. So we have our zeros of the parabola and of the wave at plus or minus 1/2. Now what I would like to do is I would like to graph these functions, as this makes it a lot easier to visualize what we're doing. And most tests will ask you to sketch the region that you're integrating over as well. So we already have our plus and minus 1/2. So that's minus 1/2. And this is our plus 1/2. And now we need to look at our maximum and minimum values of our functions, just for a perfect sketch. So for our minimum value of our parabola, all we need to look at is our y-intercept. So we already know that our parabola is centered at the y-axis, so there's no horizontal shift. So it's just a vertical shift of minus 1. So here we have minus 1. So our parabola is going to look something like this. There's a rudimentary parabola sketch. Now our cosine wave, we already know that since we have no amplitude here, then we are going to have a maximum value of 1. So it's going to look something like this. And that is our sketch. And we are going to need to integrate this region in here. Now what's important is that we know that the cosine is on the top, and that our parabola is on the bottom. So now we know which we are putting on the top and which we are putting on the bottom of our integral. All right, so now let's set up our integral. So the area is going to be equal to the integral from negative 1/2 to 1/2, because those are our bounds of integration that we determined through the intersection, of cosine of pi x minus 4x squared minus 1 dx. Now this function is an even function. So we know that cosine function is even, and we also have a parabola that's also even. So we can use our integral identity. That just means that we are taking 2 times the integral from 0 to 1/2 of cosine of pi x minus 4x minus 1. And we should have some parentheses there just to make sure that we are doing things right. So now we are going to perform a substitution. So we're going to let u equal to pi x, and du is going to be equal to pi dx. This is just for this portion of the integral, the cosine of pi x, because that is a chain rule integral. So that means that we are taking the integral of 1 over pi times the cosine of u du, and that is equal to 1 over pi times the sine of pi x. All right, so now that integral is under control, and we just have that polynomial integral to do later. And of course, that is elementary. So our area is going to be equal to 2 times 1 over pi times the sine of pi x minus 4/3 x cubed plus x evaluated between 0 and 1/2. All right, so now all that's left to do is applying the fundamental theorem of calculus. So we take 2 times 1 over pi times the sine of pi over 2 minus 4/3 times 1/8 plus 1/2 minus 0. And then there's just a little bit of algebra and a little bit of trig to do. So that will leave us with a final answer of the area being 2 over pi plus 2 over 3. So that is the answer for this final integral. Thank you very much for watching this video through deviations. In the next video, we will be doing some more algebraic work with finding the area between two curves in an enclosed region. And then after that, we will be moving to talk about solids of revolution. Thank you very much, and we will be back in the next video.